there's two kinds of driving. You know, I'm very appreciative of SAE and the regulators getting out there with the level 1, 2, 3, 4, 5 definitions. We needed something at that point in time. So no one should ever be apologetic about having introduced that. But consumers aren't going to understand that. And a lot of the regulators and investors in this space don't understand it. So I got thinking, what are we really talking about? I think there's two kinds of driving out there. There's driving where a human has to be involved, and there's driving where a human doesn't have to be involved at all. No, not in the loop whatsoever. I call the latter autonomous, and I call the former human. Now, Super Cruise is human driving. You have to be in the driver's seat. You have to be paying attention sufficiently based on the monitoring systems in order for Super Cruise to be engaged. And then fully autonomous, you could be asleep, you could be in the passenger seat, you could be reading, you could be eating, you could be texting, working on your laptop. You're not in the loop at all. So you've got human and you've got autonomous. And let's say today we go to this example in Nebraska with a nice straight stretch of the freeway. You've got history on that stretch of the freeway. There's never been a crash on this stretch of the freeway under these conditions up the road. And furthermore, my development process for my autonomous system says I can handle straight, I can handle flat, I can handle daylight. Let Larry go to sleep for the next hour. But pretty soon we're going to get into the foothills of the Rockies here, and I'm going to need him to pay attention. And I know what I need him for. It's not everything. I need him for certain curves, certain elevations, not being able to see over certain hills. And that's a different situation awareness, Brandon, than Larry, wake up. You've got 3 seconds to figure out how to avoid this truck coming at you head on. So we got trapped into the situation awareness debate, I think early on in the development of the technology, that's a human who fell asleep in the driver's seat could never wake up in time to handle an emergency. I'm saying use the telematics data and very, very importantly, extremely exciting breakthroughs in sensor technology to see much farther up the road, much clearer up the road, or much sooner up the road than we can see today, and put all that together so that we can anticipate the road ahead and know when we truly can operate. I'm talking about in a zero crash context for stretches of the road. And I think over time, Brandon, the amount of time you can spend in full autonomous will increase, and the amount of time I'm needed will decline. That means we don't have to solve all the remaining problems in order to commercialize and realize value from some of this. I mentioned these sensors. This is a bit of an advertisement, but I'm an executive advisor to a company called Neural Propulsion Systems, NPS. And we just released a paper. We just had a press release on it 2 days ago about the fact that zero deaths, which is the objective now defined by the Secretary of Transportation and the new National Roadway Safety Strategy. Zero deaths is where we want to go to. That's different than just becoming safer. Zero deaths means seeing farther, seeing faster, and seeing clearer. And we set out and assess how well do you need to see to have zero deaths. So this gets into braking distances and how fast you can see, how fast you can perceive, all of this stuff. So we do all these calculations based on information theory and physics, and we reach some pretty interesting conclusions. First of all, you need to see about 100, be able to process about 100 terabits per second of information to see in the worst case conditions to be able to have the safety margin for stopping vehicles in cities or vehicles on roads. Secondly, a human can only do about 10 megabits. So the human's about 1/1,000,000th of what it needs to be in order to see. And cameras can't get this job done either. It really requires the fusion of multiband radar with solid state LiDAR, with system on a chip technology, and some very sophisticated math called the atomic norm. The bottom line, though, is we can do it. We can see well enough to not have crashes with these technologies. So the two mode then is this combination of better sensing, better maps, anticipating the road ahead with telematics, historical and real-time data, and then knowing what you can do and knowing what you can't do, and making sure the driver's in the driver's seat when you're into situations where you need their help. I think that's how this gets. Why is that so important? It's because 80 to 85% of all the miles traveled on roads in the United States are in personal cars. That's the grand prize of autonomous driving. It's the personal car. And that's what General Motors has had as a business model. Ford has had as a business model. All the OEMs have had it as a business model. And that's what I want. Think about Economics 101, Brandon. If today the out-of-pocket and time cost of owning and operating a car is $1.50, and I think in this paper I did at Columbia, I think we're going to be able to get that into a 20 cent per mile world. What should that mean about having your own? If 85% of the people have their own car today at $1.50, don't we think more people will have their own car if the cost goes down? Yeah. So I think this future is going to be about all of us having our own personal autonomous electric connected valet that can move us around when we want to move around, that can go run errands for us when we don't even want to take the trip. And we're going to see that all play out on the world in terms of how goods and people move around and interact. And I think this two mode is a critically important pathway forward to get to that end result. Is that making sense? I'll just sort of, is it getting clearer to you?
It is, and I think there's two different places I'd want to go. So one is just kind of driving home the fact that this is different than what's being, so like Tesla's full self-driving, for example, whatever, it's an assisted driving system. It's not an automated driving system, which is what we're talking about right now. And the key difference is, I don't know, in my mind, I think of these assisted systems, the way they're being deployed right now, as convenience features less than safety features. Because if you're relying on the driver to have situational awareness and jump in the worst conditions, like you said, a truck's coming at you 3 seconds from now, kind of by definition, that can't be much safer than what the driver is doing right now. On the other side of this future that you're talking about, which is, no, we can make predictions and figure out when is this vehicle good at driving itself. Let's rely on it when it's very good at driving itself. When it's not, let's tell the driver, hey, we need you, be engaged. And then you can have automatic emergency braking. You can have other support systems for this driver. Absolutely. But it's the driver who's making the decisions.
Yeah, the driver. So maybe when they need me, it might be there's a tough left turn up the road. We know from history, given the design of the intersection and the traffic intensity, that my autonomous system is pretty cautious, and it is going to hesitate to make the decision to make the left turn up the road. I need you to look right, look left, look out the window, Larry, and tell me, is this a good time for me to make this turn? That's a different kind of driver's training than I need you to drive the car. So you're going to know when I ask you to be the human driver, we're going to know the kinds of things that I need to have you do and look out for. In fact, when I need you to be paying attention. So we're going to enhance your situation awareness around that engagement. I think that's going to make it very exciting.